Good morning, students. Once again, welcome to Maths online webinar classes conducted by our Tri Society. In our previous class, we have read about the relation between quotients and roots of the quadratic equation, finding the quadratic equation when roots have been given, and the condition of quadratic equations to have a common root. So before going into our main topics, let us recall some of the concepts which you have studied in your 10th class. So today's topics are maximum and minimum values of quadratic expression, sign of the quadratic expressions and change in signs, related problems. So in your earlier classes, that is in your 10th class, you have studied about the graphical representation of quadratic expressions. The graph will be in the form of a U-shaped curve called as parabola. So see the diagrams first of all. Here in the first diagram, the curve is not intersecting x-axis. In the second one, the curve is just touching the x-axis at point 2, 0, which is on x-axis. And in the third diagram, the curve is intersecting the x-axis at 2 points, that is 1, 0 and 3, 0. What is the difference in three of them? In the first case, since the curve is not touching or intersecting x-axis, the curve will have, that is the quadratic expression will have complex root, that is non-real roots. So if the curve has non-real roots or complex roots, then the curve does not touch or intersects the x-axis. In the second case, the quadratic expression or equation is having real root, that is 2, and it is having two equal roots. So the two roots are 2, 2. So when the quadratic expression have equal roots which are real, then it just touches the x-axis at 1 point. And see the third graph. It is intersecting x-axis at 2 points, that is 1, 0 and 3, 0. Here the x coordinates 1 and 3 are the two different roots of this quadratic expression. So this curve or this quadratic expression is having two real roots, two real and distinct roots. In this condition, when you check the nature of the curves, the delta value will be strictly less than 0, that is imaginary roots. Here, the delta value will be equal to 0, and in this condition, the delta value will be greater than 0. So see, our conditions, that is maximum and minimum values of a quadratic expression. To check this, consider the standard form of quadratic expression, that is ax square plus bx plus c. In case 1, I am considering the coefficient of x square, that is the value of coefficient of x square, a, is positive. So case 1, I am taking a as positive. Then you know that when a will be positive, the curve will be in the shape of the parabola will be in the shape of a U, upward parabola. And see the diagram. Children, from the diagram, you can clearly observe that the curve is having minimum value at this point. Okay. As we are going left and right side, that is as we are reaching the left side of x-axis and right side of x-axis, the parabola is going to infinity. Its value is rising to infinity. So the maximum value of this axis or the maximum value of this quadratic expression is infinity. So when a is positive, that is coefficient of x square is positive, the quadratic expression will have only minimum value, that is at x is equal to minus b by 2a. So in the case that the quotient of x square is positive, the quadratic expression will have minimum value at x equal to minus b by 2a, and the value will be 4ac minus b square by 4a. We got this value by substituting the x value in the quadratic expression. Now we will say second condition, that is case 2. The another condition is if the quotient of x square, that is the value of a, is negative. You know that when the quotient of x square, that is a, will be negative, the curve will be in the inverted U shape. Okay? And as we are going on the right side of the x-axis, the curve will be going to infinity. See the value here? The curve, that is the value of y, is going to minus infinity. So the maximum value will exist at this point, that is at x equal to minus b by 2a, and the minimum value will be minus infinity, so we can't find it. So when the quotient of x square, that is a, is negative, the curve or the quadratic expression will have maximum value at x equal to minus b by 2a, and the value of that expression will be again 4ac minus b square by 4a. So let us consider some of the problems on this concept. Find the maximum or minimum value of the following quadratic expressions. First one, 3x square plus 4x plus 1. And the second one, 4x minus x square minus 10. Children, consider the first concept, first problem, that is 3x square plus 4x plus 1. So, see here, what is the quotient of x square here? That is 3. Quotient of x square is 3. So, here a is equal to 3, b is equal to quotient of x, that is 4, and c is the constant term, that is 1. So, to find out the maximum or minimum value of the quadratic expression, we have to check whether the quotient of x square, a, is either positive or negative. So, in this condition, the value of a is 3, which is greater than 0, means it is positive. The expression 3x square plus 4x plus 1 will have absolute minimum value at x equal to minus b by 2a. So, substituting the value of b and a, I will get minus 4 by 6, which will be equal to minus 2 by 3. And the minimum value of the curve is 4ac minus b square by 4a, which is equal to 4 into, in the place of a, I am substituting 3, in the place of b, I am substituting 4, and in the place of c, I will substitute the value as 1. So, I will get 4 into 3 into 1 minus 4 square whole by 4 into 3. So, the value will be, after solving, I will get minus 1 by 3. So, for this problem, since the quotient of x square a is positive, the expression is having minimum value and the value is minus 1 by 3. Now, let us consider the second one. That is 4x minus x square minus 10. Here again, by comparing this expression with the standard form of quadratic expression, I will get a, that is the quotient of x square as minus 1, b, the quotient of x as 4, and c, which is equal to minus 10. Since a is equal to minus 1 is negative, the expression will be having absolute maximum value, and the value will be existing at x equal to minus b by 2a. By substituting the values, I will get minus 4 by minus 2, that is equal to 2. Means the quadratic expression will have maximum value at x equal to 2. And the maximum value will be equal to 4ac minus b square by 4a. So, by substituting the value of a, b, c, I will get 4 into minus 1 into minus 10 minus 4 square by 4 into minus 1. So, by solving, I will get the value as minus 6. Children, once observe this problem clearly. If the quotient of x square, that is a, is negative, then the expression will be having maximum value. So, the maximum value will be at 4ac minus b square by 4a. Now let us check the second concepts of sign of quadratic expressions, change on signs. In this concept, we are going to learn a new topic, that how, depending on the nature of the curves, once again listen, depending on the nature of the curves, how the sign of the quadratic expression and sign of the x square quotient are depending. Once again I'm saying, the nature, depending on the nature of the roots of the equation, the sign of the quadratic expression ax square plus bx plus c and the sign of the quotient of x square are dependent on each other. To check this concept, we are having three major theorems. So through these three major theorems, we will get this information. So in these three theorems, we have three conditions of nature of theorem. You got the information of nature of roots, how to find the nature of roots. In that condition, I have derived that it will depend on discriminant, that is delta value. And we have three conditions under the heading of nature of roots, that is delta greater than 0, that is the quadratic expression having two distinct real roots, and second is delta equal to 0, that is the quadratic expression is having two real roots which are equal, and third condition, that is delta less than 0, the quadratic expression is having two different roots and which are imaginary or non-real complex numbers. So consider the first theorem. Let a, b, c belongs to R and a not equal to 0. Then the roots of ax square plus bx plus c is equal to 0 are non-real complex numbers if and only if the expression ax square plus bx plus c and a have the same sign for all x belongs to R. So here we are getting the nature of the roots as non-real complex numbers. So the proof of this theorem, I am explaining it by graphical method. So given ax square plus bx plus c is equal to 0 is having non-real complex numbers. That means the curve should not or will not touch or intersect x-axis. So to find the relation between quotient of x square and sign of the quadratic expression, I am considering two cases. One is if a greater than 0, that is if a is positive, and the case 2 is if a is negative. So in the first case, see here, if a is positive, then the curve will be in the shape of u, which is above x-axis. Already you have observed this curve in the first slide. So since the curve is above x-axis, see here, for every value of x here, the curve is above the x-axis. See here once again, for every value of the x belongs to R, the curve is above the x-axis. Above x-axis, the value of y, that is the value of the quadratic expression, will always be positive. So since the curve is above the x-axis, the sign of the quadratic expression, that is ax square plus bx plus c, is positive. Okay, so therefore what we can conclude, if a greater than 0, we have ax square plus bx plus c is also greater than 0 for all x belongs to R. Now consider the case 2 condition. If a less than 0, what happens? If a less than 0, the graph representation will be in this form. Okay, which is the below the x-axis. The curve is below the x-axis. And children, carefully observe the diagram. For every value of the x, for every value of the x belongs to R, the value of the y is negative, since it is below the x-axis. So from this I can conclude that the sign of ax square plus bx plus c is negative for all x belongs to R in this condition. Therefore, if the quadratic equation have non-real complex roots for a less than 0, we will get the quadratic expression sign is also less than 0. So in both the conditions, what we are getting, if the quadratic expression is having complex roots, then a and quadratic expression is having same sign, either it is both positive or both negative. Now let us check second theorem. Let a, b, c belongs to R and a not equal to 0. If the equation ax square plus bx plus c is equal to 0 has equal roots, then ax square plus bx plus c and a have the same sign for all real x except at x equal to minus b by 2a. Here the condition is the quadratic equation is having equal roots. Equal roots means the delta value will be equal to 0. So this theorem also I will show it by using graphical method. Again in this condition, taking case 1, that is if a is greater than 0. If a is greater than 0, the diagram will be in this form. So children, you are observing that the curve is touching the x-axis at only one point. So which is considered as the common root. Okay. And the point is at x equal to minus b by 2a. So except at this point, the curve value will be positive. See here, at every x belongs to R, the value of y is positive. But at this point, x equal to minus b by 2a, the value of y will be 0. Since the point is on x-axis, the value of the y will be 0. So except at this point, the sign of the quadratic expression is positive. So expression is also having same sign that as the quotient of x square. And except this point, that is x equal to minus b by 2a. Now we will consider the second condition. Case 2. If a less than 0, that is if a is negative, then the graph will be in this form. See here. That is the curve is below x-axis and the value of the y is negative except at the point x equal to minus b by 2a. Since it is a point of intersection, the value of the y will be 0. So for every x belongs to R except at x equal to minus b by 2a, the value of the y will be negative. The y means it is nothing but the expression is negative. So in this case also, I can conclude that if a is less than 0, expression is also less than 0 for every x belongs to R except at the point x equal to minus b by 2a. So from this, I can conclude that if the quadratic equation is having same roots which are real, then the quadratic expression ax square plus bx plus c and the quotient of x square, that is a, will have same sign except at x equal to minus b by 2a. Now let us check the third condition, that is delta is greater than 0. See the theorem 3. Let ABC belongs to R and A not equal to 0 such that the equation ax square plus bx plus c is equal to 0 has real roots alpha and beta with alpha less than beta. Then see the first condition, for alpha less than x less than beta, that is if x lies between alpha and beta, then ax square plus bx plus c and a have opposite signs. For x less than alpha or x greater than beta, ax square plus bx plus c and a have the same sign. So in this condition, what they are saying, the quadratic expression or equation is having real roots which are different, distinct. Then the diagram will be in this form when a will be greater than 0. See here, the curve is intersecting x-axis at 2 points, that is alpha comma 0 and beta comma 0. Since alpha is less than beta, we can draw the diagram in this form. So the x coordinates of these points are called the roots of this curve, that is ax square plus bx plus c. So see, for x lying between alpha and beta, what is the value of y? So see here, red color. So when x lies between alpha and beta, between this, the y value is below x-axis. See here carefully. For the value of x lying between alpha and beta, the curve value is below the x-axis. If the curve is below the x-axis, the value of the y will be less than 0, that is negative. So the value of the quadratic expression is less than 0 for x lying between alpha and beta. And see the second condition, if x is less than alpha, that is in this direction. So x value will be from minus infinity to alpha. So if x is less than alpha, how the curve is forming? It is above x-axis and going to infinity. So since the curve is above x-axis, it is positive. In the same way, for x greater than beta, that is after beta value also, for every x greater than beta, the value of the y is above the x-axis, so it is positive. So in both the conditions, that is for x less than alpha and x greater than beta, the value of the expression ax square plus bx plus c is greater than 0. So see here, if I took a greater than 0, that is a is a positive term. So when x lies in alpha and beta, coefficient of x square and expression are having opposite signs. And for x less than alpha or x greater than beta, the quotient of x square, that is a, and expression are having same sign. So similarly, we can prove this condition for a less than 0 condition also. Now let us solve some of the problems based on this concept. Discuss the signs of quadratic expression when x is real. So already we have studied that based on the nature of the roots, we can say the relation between a and expression. So find that, first of all, we have to find the roots of this quadratic expression. So consider x square minus 5x plus 4. So by using factorization method or by using direct formula, I'm finding the roots as 1 and 4. So let alpha is equal to 1 and beta is equal to 4. So here the roots of the quadratic expressions are real and distinct. So we can apply third formula here, third theorem concept. So since a is equal to, what is our coefficient of x square value? A, that is 1, is positive. So I can apply this condition as, see here, if the equation has real roots or alpha and beta with alpha less than beta, then for alpha less than x less than beta, expression and a will have opposite signs. And for x less than alpha or x greater than beta, expression and a have the same signs. So here already the quotient of x square, that is a, is having positive sign. So I can write the sign of the expression, that is x square minus 5x plus 4 is positive if x less than alpha, that is 1, or x greater than beta, sorry, it is 4, not 1, it is 4. And x square minus 5x plus 4 is negative if x lies between 1 and 4. Next problem, for what values of x the expression is positive. Here they have given the sign of the expression, that is positive, and the sign of a, that is quotient of x square, which is equal to 1, it is also positive. So now we have to find the values of x for which both expression and a are having positive signs, same signs. So to find that, first of all, we have to find the roots of the quadratic expression. So consider x square minus 5x plus 6. So using factorization method or by using formula, the roots of the quadratic equation as 2 and 3. Taking alpha as 2 and beta is equal to 3. Here alpha is equal to 2 and beta is equal to 3. So the roots are two distinct and real roots. So that is delta is greater than 0. So we can apply third theorem concept. And see here, expression is positive and A is positive. So see here, when both are having same sign, that is expression and A are having same sign. See the condition? See here, expression and A will have same sign for x less than alpha or x greater than beta. That is x less than alpha, x less than 2 or x greater than beta, that is x greater than 3. For this values of x, the expression will be positive. Next, for what values of x, the expression ax square minus 5x minus 6 is negative. In the same way, see here, the problem is they are already given that the expression quotient, the x square quotient A is positive since it is equal to 1. So A value is positive. Now my work is to find out the values of x for which the expression will become negative. So for that I am finding the roots of this quadratic expression. So by factorization method or by using formula, I am getting the roots as minus 1 comma 6. Since alpha is the least value, I am taking minus 1 as alpha and 6 as beta. So here A is positive and expression should be negative. That is, for distinct roots, both A and expression are having opposite signs. So see the condition for where we have, so expression and A are having opposite signs. When they are having opposite signs, for x lying between alpha and beta, so x lies between minus 1 and 6. So what is the conclusion we have? For x lying between minus 1 and 6, the expression will have negative value. Now check out some of the most important problems in this concept. Determine the range of the following expression, that is x square plus x plus 1 by x square minus x plus 1. So my work is to find out the range of this expression. So since the discriminant of the denominator, that is x square minus x plus 1 is negative, x square, that is the delta, the roots are imaginary, so the curve does not touch x-axis at any place. So x square minus x plus 1 value will be never be equal to 0 for every x belongs to R. So for my this expression's value as y. So y is equal to x square plus x plus 1 by x square minus x plus 1. In the next step, bringing this denominator to the left side, I will y into x square minus is equal to x square plus x plus 1. Displaying, I will get yx square minus yx is equal to x square plus x plus 1. So bringing this RHS to LHS, I will get yx square minus x square minus yx minus x plus y equal to 0. So by taking x square common in the first two terms, I will get x square into y minus 1. And again by taking x common from the third and fourth terms, I will get minus x into plus 1 plus y minus 1. This equation is in the form of a quadratic equation in the variable x. So ax square plus bx plus c equal to 0. So here they have given that x is real. So since x is real, the values which we substitute in the place of x, that is the roots will also be real. If the roots are real, we have two conditions, that is delta greater than or equal to 0, because when delta is greater than 0, we have real and distinct rules, and if delta is equal to 0, we have real and equal rules. So since the roots are real, I can take the delta value as greater than or equal to 0. So what is the value of b here? The quotient of x, that is minus y plus 1. So substituting the value of b, a and c, I will get y plus 1 whole square minus 4 into y minus 1 whole square, which is greater than or equal to 0. By solving the equation, I will get y square plus 2y plus 1 minus 4y square minus 8y plus 4 greater than or equal to 0. So here minus 4y square plus y square gives me minus 3y square, and later plus 8y plus 2y, that is 10y, and 1 minus 4, this is equal to minus 3. So once check this inequality. So in this inequality, see the signs of y square quotient, that is a, and the sign of the expression. So later, for finding the roots of this quadratic equation in variable y, I am factorizing this concept. So I am writing 10y as y plus 9y. So by factorization method, I will get the y values as 1 by 3 and minus 3. So see this expression here again. See this expression here. The quotient of y square, that is a value, is minus 3, which is negative, and the expression minus 3y square plus 10y minus 3 is positive. That is, signs of the quotient of y square and expression are opposite direction or opposite signs. Then the variable, by our previous theorem, I can conclude that the variable y lies between the roots alpha and beta, that is alpha less than y, less than or equal to y, less than or equal to beta. So here alpha value is 1 by 3 and beta value is 3. So y lies between 1 by 3 and 3. But what is y? I have considered y as x square plus x plus 1 by x square minus x plus 1. So therefore, the given expression lies between 1 by 3 and 3. Therefore, the range of this expression is closed interval 1 by 3 comma 3. So let us check another problem. If x is real, prove that x by square minus 5x plus 9 lies by 11 and 1. Here there this expression, but we have to show that it is correct. So it is lying between these values. So for my convenience, I will consider the expression value as y. So let consider y is equal to x by x square minus 5x plus 9. So by cross multiplication, I will get y into x square minus 5x plus 9 is equal to x. By multiplication, I will get yx square minus 5yx plus 9y is equal to x. So later, if I bring this x to LHS, I will get yx square minus 5yx plus 9y minus x equal to 0. Again, by taking x common in two terms, I will get 5x square plus minus 5y minus 1 into x plus 9y is equal to 0. So this is a quadratic equation in variable x. So since x is real, here they have given that x is real, means it has real roots. Again, I can consider the delta value as greater than or equal to 0 since the roots are real. So what is the quotient of x, that is minus 5y minus 1, and what is a? The quotient of x square, that is y, and what is c? Constant term, that is 9y. By substituting the values, I will get minus 5y minus 1 whole square minus 4y into 9y greater than or equal to 0. By applying the formula, I will get 25y square plus 10y plus 1 minus 36y square greater than or equal to 0. So 25y square minus 36y square, I will get minus 11y square. So minus 11y square plus 10y plus 1 greater than or equal to 0. So I can write this 10y as 11y minus y. This is the process of factorization. Minus 11y square plus 11y minus y plus 1 greater than or equal to 0. By taking 11y common from first two terms, I will get 11y into minus y plus 1 plus 1 into minus y plus 1. So again by taking minus y plus 1 common in first two terms, I will get minus y plus 1 into 11y plus 1 greater than or equal to 0. So here, once again check the quotient of y square is minus 11. Okay, so by multiplying, I will get minus 11 y square. So the quotient of y square will be minus 11. So a value is minus 11, which is negative, and the expression is positive. So again, see it. Since the signs of the quotient of y square, that is a, and expression are having opposite signs, I can conclude by theorem 3 that the variable y lies between minus 1 by 11 and 1. So what is the value of y here? Yes. So I consider the value of y as x by So I consider the value of y as x by x square minus 5x plus 9. Since the range of y is minus 1 by 11 and 1, so the range of x by x square minus 5x plus 9 is also minus 1 by 11 and 1. So we have proved that x by x square minus 5x plus 9 is lying between minus 1 by 11 and 1. So from this, till this concept, we have completed the most important concepts of quadratic expressions. The last inequalities of quadratic expressions have been deleted from our portion in this academic year. So, by this class, we are completing our chapter quadratic expression. So, children, take today's homework problems. For what values of x, the expression 4x minus 5x square plus 2 is positive. Next one. Find the changes in the sign of the expression x square minus 5x plus 6 and find their extreme values. So here you have to show the changes in the sign of the expression as well as find their extreme values, whether they are having maximum value or minimum value. Next problem. Find the maximum or minimum value of the expression ax square plus bx plus a, where a, b belongs to R and a not equal to 0. Next one. Find the range of the expression x plus 2 by 2x square plus 3x plus 6. Next one. If the expression x minus p by x square minus 3x plus 2 takes all real values for x belongs to R, then find the bonds for p.